Welcome, everyone. It is great to have you all here at this 4IP Council's webinar on From Semiconductor to Embracing a Better Life, IP Models for an Innovation Ecosystem at Imec. My name is Ellen Deuter. I am a member of 4IP Council, and I will be your host today. As you may know, 4IP Council is a non-for-profit research organization focused on the link between IP and innovation. Our mission is to identify the most relevant topics and produce empirical research by collaborating with academics, experts, IP organizations, and other stakeholders. On our website, we provide plenty of free materials. For example, studies, guidelines, summaries of relevant papers, and recordings of our webinars, like the one today. We also produced easy-to-digest content, especially tailored for non-IP experts, SMEs, and startups. Our aim is to assist innovative startups and SMEs in learning how to use IP to grow their business. We have also gathered some of our papers into bundle pages focused on popular themes like SAP, Internet of Things, and open source software. You can check them. As you know, the Internet of Things is playing and will play a huge role in our societies and economies. One big pillar of the IoT are standards, which are often protected by patents. To help you better understand what should be your behavior as a licensor and licensee of these patents in good faith negotiations, we have created a case law area on our website with summaries on court cases. This section is now also available in Chinese and Japanese. You can follow us on Twitter, LinkedIn, YouTube, Instagram. That's a great way to find out about IP news, resources, interviews, and to learn about our future webinars. Now, without further delay, it is my pleasure to have Deepak George and Petra Kurzawski with us today. Deepak is a former integrated circuit designer and electronics engineer by qualification. He pivoted towards intellectual property when he was selected by the Intellectual Property Office of Singapore, IPOS, to be in the pioneering batch of patent examiners in 2013. Petra Kurzawski is an electrical engineer by qualification in Germany and Switzerland. She then engaged in the research in CMOS-based sensors and later worked as a production and product development engineer in the USA. As a final remark for the audience, please do not hesitate to use the Q&A tool to submit your live questions. You can find it here in the lower part of the screen. You can raise your questions at any time during and after the presentation, and your questions will be addressed once the presentation is concluded. Deepak, Petra, the floor is all yours.
Thank you, Ellen, for the kind introduction, and welcome to the webinar on IMEC. I hope in the next 1 hour, we would try to kind of briefly do our best to describe IMEC and its collaborative research and innovation model. So here we would kind of give a brief overview of IMEC and introduction to the innovation platforms run through our typical R&D life cycle and describe the different types of IMEC engagements. So how did it all started? I think so. Let's get there. So IMEC stands for Inter-University Microelectronics Center and is a non-profit R&D center that was founded in 1984 here in Leuven, Belgium, with the initial investment of 62 million euros from the Flemish government and an initial staff of around 70 really talented researchers. From there, it has kind of grown in the next picture that you can see. In this slide, you can kind of basically see that it is headquartered here in Leuven, Belgium, and it has got additional research facilities in the Netherlands and associated labs, which are kind of in collaboration with the Flemish universities. So this is the motto of IMEC, which is kind of essentially we say we shape the future. And we try to kind of build an ecosystem with our partners from companies, governments, and academia to enable the nano and digital technology innovations with a significant impact on the quality of life. You can see that how we do it is basically we try to do it based on our three pillars of our R&D, which is basically the first one is the ecosystem of more than 600 world leading industry partners and a global academic network. Bring together that with around 5,500 experts and scientists from almost 96 countries, which includes more than 800 PhD students and 50 postdocs, and put them in a world-class infrastructure, which includes a 3 billion euro 300 millimeter pilot line here in Leuven.
So maybe you want to mention that 300 millimeters is 12-inch for.
Yeah. So here is basically what you see the facilities at the Leuven HQ, where you can see the different labs, how they have been distributed around the HQ, and how it's and it started off from a small building, and it has expanded to these different facilities that are there. In this slide, we can it shows the collaborations with the Flemish universities and how the different R&D groups are embedded within the associated labs within the Flemish universities and the activities that are carried out under those associated labs. Yep. So all throughout, I had kind of described IMEC as Inter-University Microelectronics Center. One of the main research focus of IMEC is to drive the semiconductor roadmap, and it has been doing so for the last 35 years. And this would be a recurring theme later on. So I thought like maybe we take a step back for those who are not from the sector to give a context of what semiconductor is. So semiconductor is an essential component of the electronic industry, and so the wafer that you see in the hands of the person is basically the 300 millimeter wafer. And these are materials which have the electrical conductivity between that of a conductor, such as a metal, and that of an insulator, such as a ceramic. And this property allows them to be the basis of devices such as transistors, diodes, and integrated circuits. And and as the electronic industry continues to evolve rapidly with new technologies, semiconductors is playing the key enabling role to the growth of electronics. And in that way, it has become pervasive into multiple areas. Here you can see IMEC has been set up in 3 large technology R&D platforms. That's how we kind of arrange ourselves. The main one is the semiconductor and the systems technologies, where we try to, which comprise of the advanced research on process technologies, on CMOS, and then drive towards miniaturization. From there, we also engaged in the sensor technologies and technologies for flexible electronics. And through these 3 focus areas in research, we try to kind of look for opportunities which are beyond the traditional microelectronics boundaries. Adjacent to that, you see the digital technology platform, which brings together areas like networking, digital privacy, software, data management, and then combining the insights from these 2 technology platforms. The idea is to bring work on the application domains and hopefully bring in some leading cutting edge applications in the areas of health, mobility, cities, agri-food, etc. So that's kind of like how IMEC is organized itself into. As a first takeaway here, I think the first thing that we would like to convey is the networked innovation approach, the collaborative approach that is there in IMEC, which brings together the researchers from the industry, from the universities, from funding from the government, funding from Europe, and under the umbrella of IMEC. After that, I would kind of hand over to Petra to walk us through the IP considerations.
Yeah. So Deepak gave us a brief introduction on how the setting is of IMEC. I'm gonna work a little bit on what does it actually mean, the R&D scope of IMEC, right? And so here we have a slide on the R&D life cycle, right? So basically, Any research starts at a very low TRL level. So basically, there is no technology readiness yet, right? We start at the fundamental research, right? And then over time, more and more people work on it, and so the technology readiness level gets higher. So that's basically indicated by the horizontal arrow here. Imec actually does engage in along the whole technology readiness level, because I'm referring to that, right? So we see on the left-hand side, we do see the fundamental research, right? Like the essential, how do diodes work and so forth. That is typically very much also on government or European-funded projects, actually. So a lot of collaboration then also with universities and academia. Then in the middle part is something that we call programs. It's very unique actually to Imec. It's like a midway where we basically take up those fundamental learnings and actually put it into more platform-related research, but working together with industrial partners to actually then aim for a better roadmap, aim for knowing actually in which direction we better have to develop our technology platforms, as had been presented before. And then on the right-hand side, again, going back to the technology readiness level when things are more mature, right, a higher technology readiness level, that's actually where Imec does also engage in so-called IP monetization. So we do offer services as, for example, low-volume manufacturing. There we have projects where we develop on demand. We also engage in tech transfers. We have IP licenses. We will have a little bit more detail later on the spin-offs, how we actually engage there. And we also had ever so often a patent sale. So this is a slightly different representation actually of that R&D life cycle. Here more in view of the share, what does it mean in terms of share of IP, share of cost, and share of risk as well. And so again, on the left-hand side, more like the fundamental research where we engage in the open research programs as it's named here, but it was basically the fundamental research, mostly then also paid by or funded by government or a European agencies. Then we actually move along that middle bar where we actually have the research programs, where we also engage a little bit more in so-called joint development projects, where it gets a little bit more specific in the interest of a certain industrial partner. And then on the right-hand side, we have actually the prototype product development. And there you also see the shift basically from the previous shared IP, cost, and risk, and that kind of the pre-competitive phase into the proprietary and exclusive IP, where the customer would carry the full cost and where it then actually goes into the competitive region. Okay, so IP considerations, we try to keep it somewhat brief. It is basically true for any of the projects, thus also contracts that we actually engage in. So we have to know the general scope, right? So who's the partner? What type of collaboration is it, right? Is it an evaluation of feasibility? Is it actually something like a joint development agreement? Because that also determines the need of the respective parties to this agreement. What is the term? Do we have to foresee long-term or short-term? Maybe also blocking aspects, I don't know. And then where in the R&D life cycle does it actually fit into, right? And so IP aspects is there, if we look at a project, right, we get an outline, it's called the technical annex, right? What kind of background do we actually need? Are there patents? Is it know-how? And what kind of foreground will actually be created under this project as far as we can foresee? And what kind of type would it be? Is it data? Is it processing technology? Is it software creation, for example? And we also take, when we look at the potential results that will be created, is also a consideration of if this would be a generic, so the potential usage in several different applications, or is it more specific in nature, right? Do we need to consider third-party IP, right? Do we already have a license on it, or do we need to do further licensing in? Then also in consideration, how the foreground is created, how will we assign the ownership on it? and what are the licenses that are needed during the project and also after the project by the respective parties, right? So, and then if, say, for example, there's a license request on our background or the other party's background, then we also have to take into considerations like license fees, for example, that can be in lump sum payments or also in royalties. And then also if joint IP is a consideration for this project and discussed thereunder, then also we typically put in provisions of the filing and maintenance of formalities. So how are we going to actually engage when we have joint patent filing, for example, right? We also have to see all of these aspects in consideration of other terms or provisions of the contract. Confidentiality is a really important aspect of it. How do we deal with publications? What are the representation warranties that we take, for example, also on the IP, right? Export control, also with licenses, is a relevant aspect, especially since more or less recently the regulations have changed. Liability, and then also survival of rights. So just as a general principle, because you've seen like the wide spread that IMEC is engaged in, and especially like the open research, and then also the IMEC research programs actually delivers our basic guiding principles as displayed here, right? So what we do try to do is avoid IP blocking for IMEC and its partners, and then also secure the IP rights that we actually further would need. And then here we used as a last bullet point the freedom to operate. I don't want it to be misunderstood. It basically and underlines the previously mentioned two bullets. It basically means that actually we want to ensure that that we're not blocked in our own technology or what we already have background on, right? So we want to keep the research paths that we're trying to maintain. We want to keep them. And I will hand back to Deepak.
Thank you, Petra. If you can go to the next one. Yeah, so like what Petra had mentioned in the previous slides, that we operate along the whole spectrum of R&D readiness levels, and there we would try to have, and we are kind of, the IMEC offering is divided up into three bundles, if we can say. One is the collaborations, the research collaborations that are there. The second one is typically the development, which is more onto the services. And the third one is entrepreneurship, which is more into the venturing and the startup. Under the collaboration bundle, you will typically find all the bulk of the activities, which are basically developing of the new range of technologies, applications in advanced semiconductors, the research on the manufacturing processes, on energy efficient computing architectures, sensors for medical or environmental monitoring. So most all the research activities are bundled under the collaboration heading. Under the development, you would find the services that would be there for bringing these research into the market, and under the venturing, you would kind of bring in the entrepreneurial aspects of it. One of the key driving aspects of IMEC is in the collaboration space is the semiconductor, to drive the semiconductor scaling roadmap. And what you see here is the current status quo. So we are at FinFET stage, and what you see here is how do we take the semiconductor scaling towards a sub 1 nanometer. Now, let me take again a step back, like what I did for semiconductors before, is that what is a semiconductor roadmap? So it's basically a long-term strategic plan that outlines the basic evolution of the technology over time, and this is typically done through kind of projections on key performance metrics, which is the transistor density, the power density, the area, clock speed, memory capacity, etc. And it kind of helps to drive the whole ecosystem forward, the manufacturing processes, the new device architectures. The semiconductor roadmap is developed typically by a consortium of industry players, which is the International Technology Roadmap for Semiconductors, which is ITRS, or through semiconductor industry associations, and IMEC plays a key role in both these organizations. Within IMEC, we bring together the whole ecosystems, because this is an ecosystem driven initiative. We bring together the whole ecosystem, including the academia, industry, under one umbrella or one roof, to be more precise. And then it tries to kind of push this roadmap forward and keep it going forward. One of the examples that you can see recently that happened would be kind of the work under the EUV, the extreme ultraviolet lithography, which is a key manufacturing technology for advanced semiconductors, and the role of IMEC, which in developing these the baseline technologies under for these kind of lithography and organizing the ecosystem around it. So that's one of the key areas there. So that's kind of the framework that allows. Typically, the roadmap is driven by power, performance, area, and cost. Increasingly, we want to the industry feels the need to be making more sustainable manufacturing choices, and in order to drive that kind of an adaptation, IMEC has launched a new program where it kind of tries to enable. If you can go to the next slide, please. Again, bring together all the members of the ecosystem, which is basically the material suppliers, the equipment suppliers. When we say equipment suppliers, it is the semiconductor equipment manufacturers, the fabless and the fablite, into a space where it can unite all of them into the value chain and jointly develop methodologies and processes and materials to have a more sustainable chip manufacturing industry. On that initiative, there is a new program that is kind of being launched where it tries to assess the impact of the different choices that the industry takes and the different methodologies, and then based on that input information, come up with new solutions. So that's basically from looking at it purely from a sustainability point of view. This kind of shows another view of IMEC. So IMEC is based on its core semiconductor technology as a foundation. From there, it tries to bring up the technology platforms where it kind of like builds on its know-how on manufacturing and processes to build logic, CMOS, memory, 3D structures, photonics, MEMS, sensors, and flexible technologies. Bringing that one level up, you try to bring that into systems and systems on chips architecture. So you bring in an architectural level, try to build up platforms for DNA sequencing or RF technologies or lens-free imaging, and then using all of them, combining it with a digital technology to kind of bring in new applications. So that's kind of putting that thing back into the perspective. And then I think I will hand it back to Petra for giving some more insight into the application domains and move it forward.
Yeah. So it's kind of like putting that into perspective and actually have like a little bit more tangible examples of like how we actually could use the platforms to actually apply them to certain domains. So overall, IMEC is basically looking into 8 big sectors, but it's not only this, but these are the 8 that we typically how do you say, like advertise? Advertise. I'll put it that way. So I'm going to focus a little bit on 2 of them. Yeah. So one big topic actually that again has come up, and I think also with COVID and like personalized treatment, because like different people would actually react different to a certain treatment, right? Is this personalized treatment? And so what is actually relevant for such personalized treatment is you have to know actually how people individually react. And typically what is used there is the DNA. Deepak had also mentioned it as one of the system platforms from IMEC, right? So we do DNA sequencing basically to enable this kind of like precision medicine, right? And so the genetic makeup that the DNA contains, right, should actually like viewing on how DNA reacts to certain, it's called screening, right? Reacts to certain medication, for example, should also indicate which treatment should be done. But I'm going to show in the next slide an example actually where we don't go specifically for the treatment. Oh, hold on. No, I forgot about that slide. Yeah,
the use of semiconductors in
yeah, I know we shifted that slide early on, that's why it's a little bit out of order. Why is actually the semiconductor technology such an interesting approach actually for these kind of like DNA sequences, because there are also other methods out there, right? But the advantage here is actually the miniaturization. All right, it's a big advantage then, and then also the ways to integrate. There will be on a different application. There will be an example in a little while. Then also due to the miniaturization and the way that the process technology is set up, it enables mass production with a high yield, and then basically also due to those factors, overall the cost per system component per device basically would go down. And so in the next slide, just how we actually use the DNA sequencing chip. Actually, one of the collaborations that we have and still have is PacBio. It's a very strong relationship. And so basically, in the past, PacBio has engaged with Imec to further work on this sequencing application. And so due to the progress there, the miniaturization and so forth, what together we were able to achieve is basically that the system that you see on the left, that was the older one. So to develop the system on the right, which is then basically 7 times faster, 3 times smaller, and then also at a 2 times lower cost. Different application would be, for example, mobility. That's also in the interest of I would say most people. Yeah, so what is often discussed is basically smart mobility, right? What does it actually mean? So mobility can be seen as different aspects: mobility in the car, mobility with the cell phone, and so forth. I think the overall goal is to actually integrate and have basically the systems communicating with each other. So in the aspect of like smart mobility in the connection of a driverless car, I will actually just show some examples on like what Imec is working on. If you go to the next slide. So cars do have a lot of sensor systems, right? A lot of them used for ranging, right? So adaptive cruise control, parking, distance warrant system, cameras, and so forth and so forth. And so here's an overview of like some of the systems that are actually used, right? So we do have cameras. We have radar for the longer range detection and ranging, and then lidar currently still for the shorter range, but they're not only on Imec side, but several institutions, companies, and so forth are actually working there on the wider range. Then of course we also have to have GPS, right? Everybody is heavily depending on the navigation system, and then also ultrasound. And so Imec is working on some of the aspects. We go to the next slide. So for example, we have the lidar, right? It's a light. It stands for light detection and ranging, right? So it basically works with a laser that sends out the information, sends out a light beam, it's reflected, it comes back again, and then basically the information thereon is deciphered, right? We get information about distance, for example. And so Imec is heavily working on that as well, using this so-called silicon photonics / silicon nitride platform, having the advantage that we don't have like any mechanical parts there. Yeah, so, and here it's also referring to the optical beamforming. So the better I can control my laser, basically, the better the information I actually get fed back. Yeah, so we also briefly touch upon like that there are cameras, right? And so Imec is also working on imagers, basically, or on camera systems. What is often used, but it heavily depends on the application, is so-called shortwave infrared or near infrared imagers that can also be used in a car, for example, to differentiate between what the objects are, because they would feed back a different kind of wavelength So we have then we have the spectroscopy, right? So they would reflect back a different wavelength that could then also indicate on like what the object is in a better way. It's more contrast related in a better way than, for example, lidar could do. Then this would be an example of our radar chip, for example, on the 140 gigahertz, also for the use of automotive driving. This is an example of basically how we actually integrate different systems for using our technology. So it's not only the platform itself, right? So making the chips, but also how do we combine or integrate or package the chips. And this is an example of something related to connectivity, basically. So this is about the 5G and 6G efforts done by Imec. And basically here you see then the integration of like the antenna, then also working with different types of materials, the 3.5, which would basically in this case, I don't know, it represent or could be a laser, for example, and then basically the stacking so that we also have the combination. Here we have optical circuits, so-called PICs, photonic integrated circuits, but then also in combination then with the electrical integrated circuits, because in the end we need an electrical signal to basically and also feed it into, say, for example, the computer of the car. And if you go down. Thank you. So we have what we've seen as an example for the car, and then also for the hopefully at some point, because I'm tired of driving, the fully autonomous driving, right? But we have all these different sensors that give us all these different kind of information, and we have to combine all this information and make sense of it, right? Because at the end we need the car computer needs to make a decision. What is now the next move that it should do? Brake, move forward, whatever, right? And so basically, if we want to look at combine the information of many sensors, this is when we talk about sensor fusion. And so because it's also pretty tough to handle so much of data, that is where our digital technology platform comes in. This is where we would, for example, also work with their artificial intelligence, like with new computational networks, to basically combine the data and actually find a good way to filter and to provide the necessary output. So I'm going to go back to this slide on what Imec offers. So I hope we gave a brief overview on the different types of R&D collaborations that Imec is involved in and what we do. Just briefly on the topic of development and venturing. So for the development, we actually stated that Imec also does on the more mature platforms, does also offer services. And if you go to the next slide, I'm just going to mention part of the services that we offer. This is something that is offered to universities, to small and medium enterprises, also to startups. So because Imec has the supply chain, they have the knowledge and so forth. So different types of services, which might be, for example, an ASIC design, and then also the manufacturing of the ASIC, or the packaging, in the end, then also for then as the company then grows, then maybe also setting up the supply chain there. So this is what Imec.IC actually does. IC-link does. It's a little bit broader in the way what they offer. Imec does not only work on our own technology platforms, so it might also be that actually, say, we design an ASIC chip, right? That is then done on the TSMC CMOS platform, for example. EuroPractice is a little bit different. It's not that we actually would provide like the design or the package part or a prototype. EuroPractice is more about minimizing the costs actually for the customer. So if you are in a prototype development, for example, you will get access to the so-called design kits. You can design your own chip, and then it will be the wafer lots. So the wafers will be shared. The space on a wafer is very costly, so it will be shared. with your design, also other people will provide the design. And then basically when the processing is done, it's cut up, and then each customer gets their respective part, but it reduces the overall cost. And I also think, yeah. We also, so I'm just going to briefly touch upon this again to recall, for you to recall the innovation platforms. So for the R&D collaborations, I'm actually trying to merge it all and combine it in such a way that it applies to certain applications. In view of the venturing, it's a little bit different. We look at the two bottom platforms, basically, and if you go to the next slide, I'm just going to explain why. So there are two, I want to say vehicles, but it's not really the right word to use, but there are two vehicles to actually to be used. So for the digital technology platform, it would actually be Imec.IC-link, which is a business accelerator and a startup incubator actually for startups in the digital domain, so software. And it's an interesting concept because you can apply there, and if you're accepted, they would also offer you a 12 to 18 month training program actually to prepare you on like what does it actually mean, how do I place myself on the market, things like that, financials, also human resources, and so forth and so forth. So it's a quite interesting program. For the hardware related projects, well, startups, I have to say, right? It would be Imec.Expand. It's actually an independent venture fund that preferably, well, exclusively works with Imec, I have to say, although exclusively means not necessarily that the startups are all Imec born, so it might be also external startups, but their objective is actually that they work together with Imec and Imec profits from it. And so it could be that, say, there is a development with said external startup, or they do a low volume manufacturing with Imec. But very often it's actually Imec creators of said startup, and so there's as displayed here, a certain procedure that they have to go through as they present the idea, and then it goes through an enrichment phase where market aspects are seen, the technological strength actually of the innovation, how is it seen in the landscape and so forth. And so it goes through several of these circles. It's kind of like gates, quality gates, I would say. And then it goes into the development phase, and if it fulfills certain criteria, that's actually where then Imec.Expand would then also, together with other venture funds, invest. Here, just a brief example of like, I think several of the spin-offs. I don't know if it's all of them, but several of the spin-offs created since actually, I think in the last 30 years, right? Yeah. So we're just going to finish our talk with the corporate values.
Yeah, thank you.
Thank you very much.
Thank you, Petra. Thank you, Deepak. So interesting to learn about all these topics. And we have already some questions here in our Q&A. Our audience is curious to learn more. So I'm going to start then with the questions. We have one here. Two of them are related. So I will start with that. Do you believe that the European Chips Act will boost Europe's competitiveness in the semiconductor sector? This is one of them. And maybe we can combine. I will read again, but I think we can combine with the question, where does Imec fit into the ongoing Chips Act legislation?
Well, I think they are both related questions. And since Imec is kind of like a nerve center of a lot of the semiconductor related activities, it plays a crucial, it plays an active role in the CHIPS Act legislation, and in collaborating with all the partners within the governments, within all the consortiums across the globe. So especially the European CHIPS Acts, but also the other CHIPS Acts which have come across. So we are active in all of them.
Thank
and
you.
Will it boost the competitiveness of the semiconductor sector? Oh, well, the sector is kind of competitive always. And I've been in the sector for 25 years, so and I had the opportunity to see it from multiple angles. It had gone to one mode in which it's always striving towards optimization in the supply chains and stuff like that. With the disruptions that happened through the pandemic and the geopolitics, some of those realizations on those kind of extreme optimization of the supply chains and the disruptions were kind of noticed, and that's where kind of I think now there is more drive towards bringing in some of more resilience in those supply chains. So that's where I think more of the maybe a competitiveness aspect will come in, and for sure it will be there. Yeah.
Thank you very much. We have more questions here. The second one is, could you talk about the nanopore technology? How does it work?
That goes into life science. I don't know a little bit about it, but I think that might be actually to divulge in it might be a little bit dangerous, because then my knowledge is actually too limited. So,
but I would kind of advise that we go into the IMEC website, and there's a lot of kind of much more deeper insights in there with specific areas that you can potentially come to. And then there are also other research papers that IMEC publishes on a regular basis. So I think that would kind of really give you more insights into it if that helps. But yeah, unfortunately, both of us are not.
We're not in the life sciences
from that domain, so we would not have heard an answer on that topic.
No problem. Thank you very much. And the next question: as a deep tech startup, who can we contact from IMEC to discuss a partnership, collaboration? You mentioned the programs iStart and
yeah, the question is if you still need funding, basically, right? Then it would be IMEC Expanded to reach out to, and I think in the slides that will also be provided, there's also a link, but otherwise you can just Google it. Yeah. If it's about more of the collaboration in like like an evaluation or say like development, or in that respect, actually that would be through our sales team. Also there the link can be found directly on the international. Otherwise if I actually know, like I give you a free way here to contact me directly. If I know exactly like what the topic is, then I can actually also direct you to the right person within IMEC.
Indeed.
Thank you, Petra. Wow, the questions are arriving. We have many of them here. Let me check. How does IMEC collaborate with established chip makers? How do you deal with foreground IP?
Well, I mean, we have ongoing collaborations with all the established chip makers, all the major chip makers, Intel, Samsung, and all of them. And typically, many of the key chip makers are our co-partners, so they actually drive our roadmaps as well. And they and how it works, as we saw in the previous slide from Petra, is that we have the whole funnel of collaborations where you can go from a pathfinder kind of a project to more dedicated projects. So we do have like a whole range there. And each of those particular projects might be specifically carved out. So that's our activity as an IPBI person, to kind of negotiate the IP model which is specific to each of the collaboration and the models that is applied to it. But the program model is typically where most of the established chip makers come into IMEC.
That is, I'm just going to briefly, because you use core partners. So core partner is basically a partner like one of these chip makers, actually, who are engaged in these programs, right? Which are very open, shared IP, right? We try to share risk and costs in basically furthering the technology.
Yeah.
Thank you very much. We have more questions here. So another one is, as a student, how can I collaborate with IMEC?
So actually we due to another thing we were just discussing earlier on. So as a student, there are different ways actually how to engage. Typically, it is through a university. So we have a lot of PhD students, for example, as you've seen on one of the previous slides. As far as I know, you can also do internships. So my advice would also be that to go through the IMEC webpage, actually, there is a part where it says career academic. And I believe that as a subsection there, you can also see how, as a student, you can engage in IMEC and with IMEC.
Thank you, Petra. Another question. This is super interesting. What is for you, Petra and Deepak, the most exciting part about working at IMEC?
I will let Petra answer first, and then I'll probably take a stab at it.
Well, I like the variety of the technologies, right? So I really have this. There's always something new to learn. I've only been with IMEC for 4 years, but I think there will like, even, you know, if I look at my colleagues who've been with IMEC a little longer, there is no end to learning, and that is actually, I think, not everybody can say that about their work, right? And but yeah, I mean, also you've seen like in our R&D life cycle and how we actually engage then in these different kind of technologies and so forth, right? There's always new projects, it's always different. There's a new challenge actually. Yeah, so yeah, that is my exciting part about it.
Yeah, I think if I take a leap out of that, I think for me it's basically looking at the whole semiconductor ecosystem under one roof. So I'm a kind of like, that was the first thing that I noticed when I first joined IMEC 4 years back. We joined around the same time, and when I was sitting in one of those internal conferences, is that we actually have under one roof all the different elements of the semiconductor ecosystem. They interact with each other. There is a lot of when you're in the industry, there is a lot of competitiveness, but here you see them collaborating with each other to create these new solutions, and I think that gets me excited and working on these new solutions. So that's my take on that. Right. Yeah. So yeah.
Thank you very much. We have another one here. What is your approach when it comes to IP monetization, licensing? How do you identify patent implementers? How do you enforce your patents in case of resistance? So
maybe I can. So one of the main approaches that we do for IP is through our program memberships. So that's kind of like people subscribe to our memberships and to our programs, and part of the subscription, if there's a new program, you kind of like already get access to our foreground IP. If you're joining late in the program and there is already existing background, then you pay a certain amount of background fees, and then you kind of like enter into the program and then get access to the further IPs that are there. But as we had seen in the spectrum, like apart from the program, we also monetize it through spin-offs and multiple ways. So you kind of like, we have the whole range there. How do we enforce our patents in case of resistance? Well, it will be like any other thing. We send a kind letter, but we rarely have got into that situation. But
no,
I think
there have been cases, right?
Yeah. So, but it's usually
the last 4 years, actually.
Yeah.
To say, but yeah.
But it's usually the usual ways to enforce. So nothing different there.
Yes, thank you very much. Another question. What do you think are the fastest growing technologies that we are going to hear about in the near future?
You want to take a stab at the crystal ball?
That will be interesting to hear.
Yeah, it's really hard to say, right?
Yeah, I mean, it's basically difficult to hazard a guess there, because often you can be proved wrong. And the main thing is that you get insights as an IP person. You see the contracts running from, let's say, a Pathfinder, which are like really early technology. Some of them you might be really excited to see them coming up, and through the spin-offs, and there are multiple factors, not just technical, but there are other various factors that leads to a success of the technology and becoming a trend. So looking at it from one angle and predicting something is difficult, but maybe the one thing that we can predict is that semiconductor technology keeps on moving, the roadmap keeps on moving. That's what you see in the presentations. What you see there is basically the work that would be carried on for the next 10 to 15 years on how do we kind of miniaturize these semiconductor devices and stuff like that. And that would definitely lead to lots of interesting applications that you already see around. So look out for the bright future, I would say.
Thank you. The next question is, are smart cities a way to move towards a more efficient living? How much do you believe cities and homes will change in the future? Another turn for your crystal ball.
No, we already. I believe we already see the impact, right? Like how is that actually used, right? I mean, I'm gonna just mention Alexa. I know that a lot of people have it, right? Or the way that you actually implement smart into how homes with your program the lightning and recognition when you're home and so forth and so forth. And we also do see it more and more in like what's called the smart cities, right? The implementation of more sensors, the interacting. You have apps on your phone, right? So it will increase. It will increase. It's also because it's also conceived first of all to the advantage for the quality of living, right? But I also think out of the necessity to monitor also certain things, right? So smart cities also using sensors to actually monitor what is the air pollution, right? How is the usage of like certain streets at a certain time, maybe to minimize the consumption for the lamps and so forth and so forth. So yeah, I don't need a crystal ball. It's for sure it's gonna increase. Yeah,
it's just there, and,
yeah.
And you can see from the last slide, from the mobility slide, that you can see that the various sensors are brought together with the fusion, the sensor fusion kind of a method, where you have the data coming together with the digital applications to come up with smart solutions. So these are all just happening, and it will keep on going forward the way it is. Some point it will accelerate way more than this.
Mm-hmm. Yeah, it's quite exciting to think of the examples in our daily lives. Maybe then one last question. We have many of them, but unfortunately we don't have the time to cover all of them. So the last one is, how many resources does Imec place into each one of the three main activities? For example, the percentage of revenues, considering the main three activities.
So as far as I know, I should be following up this a little bit better, right? But I know that the revenue despite Corona, actually has increased with Imec, and I believe that for last year it was between 700 and 800 million euro, right? So now I lost my thread.
I think from the activities point of view, the bulk of the R&D is focused on the silicon photonic. In the silicon, the core silicon triangle, the big one that you see. From there, you kind of building the resources and the sensors and the applications. If you look at the venturing part, those are typically, and those are independent activities that are there. So that's out of the scope of this particular set of revenue that we mentioned. So that's an independent thing. So that's completely different. But it's a non-profit, and you can see all the financial details on the website. I'm pretty sure it will be available. It's publicly available.
Yeah, but I could not give a percentage. I could not say like 70% of Imec's research actually work then on some.
Yeah,
I would not. To be honest, I would not know.
We wouldn't have that thing, but I think it's the one thing that we have seen over the years from 1984 to now is that the percentage of contribution from the government to the industry has changed. So earlier it was fully funded from the government. Now it is almost 70% from the industry, and 30% we still get the public funding, and that actually keeps us relevant to the we need to strive to be relevant to the needs of the ecosystem.
Thank you, Deepak. Thank you, Petra. As I said, we have so many questions. This is a topic that can be discussed for hours, if not days, but it's now time to conclude. Thank you so much, Petra and Deepak, for sharing your knowledge and expertise. Thank you also to all of you for attending this webinar. Tomorrow, you will receive an email inviting you to complete a 1-minute survey about this webinar. We would be very grateful for your feedback. As explained before, a recording of this presentation will be made available on 4IP Council's website tomorrow. Don't forget to register for the upcoming webinar, Finding an Efficiency-Oriented Approach to Scrutinize the Essentiality of SEP. You can find out more on our website under webinars. Thank you again, Petra and Deepak. Thank you all.
Thank you, Ellen.
Thank you, everyone. So,
Thank you,
bye.
everyone.
Bye.
Bye.
Bye.